Morning, Cappuccino students. It's Mrs. Valletta. I've come back to Cappuccino to do a quick little experiment for you. I know that you're working hard on your power plant presentation and you're trying to understand how they transfer energy from one form to another. So I want to have you take a look at convection currents. I'm going to have you visualize it. It's a lab that we would have done had we been in class. And I want to remind you that in your turbines, usually we're generating steam, so we're combusting a fuel or using radioactivity to boil water, and the steam has a lot of kinetic energy. It rises because it becomes less dense. Those molecules are bumping into one another, and the faster they are, the bigger the collisions are. In other words, the more transfer of momentum and the larger area they take up. So they become less dense. And you know the saying that hot air rises and cold air sinks. Well, that's a convection current that gets set up. So I've come to CAP today to set up a convection current for you. What we have here is a tank of water that I've elevated for you. And I've got hot water that I boiled in the microwave and some just tap water that's cooler. And what we're gonna do is I'm gonna put the cups of water underneath the sides. And this is a little bit hard for me to do, so hold on one second. All right, so on the hot side, I'm gonna put 2 drops of red dye. Remember, all I do is I have hot water underneath. And on the cold side, we're gonna put 2 drops of blue dye. And now we're just gonna wait and we're gonna see what happens. Actually, a little less drops. Let me put 1 more. There we go. That's a little bit more even. All right, and so I just want to remind you that we don't even have hot water directly in there. What we have is steam that's touching the bottom of the container. And what we know is that temperature is a measure of average kinetic energy. So hot molecules are moving faster. Now, if hot molecules are moving faster, that means they're having more collisions, then they're having more transfer of momentum. And so what we're already seeing over here is that on the hot side, the molecules are spreading out more. They're having more energetic collisions and they're taking up more space because of that. They're spreading out more. So this is the old saying that hot air rises and cold air sinks, has to do with how much kinetic energy. All right, so let's give it a minute and see what happens. You can see the red water is on the march. Remember that it's not anything special about these dyes. These dyes are just marking our convection current. They're allowing us to see water movement, which we normally can't see. Okay, so let's take a look. It's been almost 5 minutes. If we look at the side, most of the cold water is still in the corner. A lot of it's sunk to the bottom. Most of the hot water now is risen to the top, and it's almost over to the cold side. So we'll see what happens when that hot water gets to the cold side. Make a prediction. Okay, so it's been about 5 minutes later. You can see the red dye is all over the tank, and the blue dye has sunk to the bottom. Now, interestingly enough, as the red dye comes to the cold side, what you'll see is the red dye starts to sink down. And that's because the water is cooler on this side of the tank. Remember, we've got cold water here, and that's chilling the bottom of the tank over here, and that's causing the water molecules to slow down, and as they slow down, they're becoming more dense. On this side of the tank, what we're starting to see is that there's not as much heat, and so they've spread out about as much as they can. All right, that's it for Science at Cappuccino this week. Hope your power plant projects are going well. See you online on Wednesday. Bye now.